I'll be here.
Okay, ready? Say it again.
I won't be here.
You can take it on Saturday before you leave.
I won't be here Saturday.
Friday before you leave.
Friday.
Thursday before you leave.
I'll be here Thursday.
Wednesday before you leave. I can't, don't do this to me. I don't want to give a 0.
I mean, I told you this like 2 weeks ago. I can't
You
take
did?
it after Monday. Yeah.
We have to talk about it. I would rather not, because if I give you extra time, then I have to give everyone extra time. That's what I think it's fair to everybody.
I'm sure
So
they
this is
wouldn't
May
mind
the
that.
7th?
Yes.
Okay.
I don't have a problem having the final on Wednesday, but I don't want to have to put a 0 for the final for anybody.
Okay, Wednesday. I won't be here. Wednesday till that Tuesday.
The following Tuesday, the following Wednesday.
Yeah. I'll be here that following Wednesday, just not from Wednesday till Tuesday.
At the end.
Okay.
Okay? So I don't have a problem with having the final on Wednesday for everyone, just to make sure that everyone shows up. Now, can you take it on Tuesday if you're not going to be here on Wednesday?
Well, I'll be here Wednesday. I won't be here Tuesday. So I'm leaving the Wednesday. We'll talk about that. Yes, let's look at a calendar.
That's what I'm trying to get to. Because I need to solve this here right now. Because I don't want any surprises. There is always, I shouldn't say always, but very frequently, a student goes astray, doesn't show up, and I have to calculate the grade with a 0. I don't want to calculate the grade, anyone's grade with a 0 on the final. Please help me. Please, I'm begging you. Okay, so it's either May the 7th or May the 9th. Which one?
May 9th. I won't be here May 7th.
Okay, is everyone okay with May 9th? Wednesday. Okay, so please mark your calendars. Final exam, May the 9th, everyone here in this room. Okay? You can start early and you can have extra time if you want to.
Start early, like before.
I'll be here from 4 p.m.
So whenever we're ready.
Whenever you're ready. So starting from 4 p.m.-ish. Okay, so clear, everyone? Everyone okay? In agreement? I will call you. I will step outside and call you if you don't show up. So please don't do that to me. Please, I'm begging you. Okay, solve the equations. A, B, C. Which one we start with? Okay, very good. So we have 2 to x minus 2 equals 3 to 3x plus 5. What type of equation is this? That's my first thought. I need to know the type of equation. What is the equation? It could be absolute value, it could be rational, it could be square root, it could be quadratic. Exactly. It's obviously exponential. Good. My next question is this to myself. Can I present both sides with the same base? No. Awesome. What is the only chance I have now if I cannot present both sides with the same base? What is my only chance? Of course. It doesn't matter which one you apply in this case because there is no base E and there is no base 10. You can use base 10, you can use base E. And I don't want to forget also, please tell me, not later than Wednesday, how many of you want a math lab test and how many of you want a written test? Okay, so I need to know how many copies I make for next Monday. Okay, and the final as well. Okay, so what will be the next step? I have to bring the power in front, in parentheses, as a factor. I have to bring 3x plus 5 in parentheses as a factor. If I don't put it in parentheses, I mess up the entire problem. Okay, so what next? What will be my next step, please? Yes, distribute. Very good. X natural log 2 minus 2 natural log 2 equals 3x natural log 3 plus 5 natural log 3. Awesome. Very good. Well done. Next. Say it again. I just didn't hear. I have to move 3x next to the other term that has x, and I have to move this one next to the other term that does not. If that's what you said, I agree.
That's what I meant, yes.
Good. Perfect. So x natural log 2 minus 3x natural log 3 equals 2 natural log 2 plus 5 natural log 3. Awesome. Next step, please.
Factor out A.
Very good. Awesome. Well done. And in parentheses,
Natural log 2 minus 3 natural log.
very good. And then 2 natural log 2 plus 5 natural log 3. So then x equals 2 natural log 2 plus 5 natural log 3 divided by this number. Natural log 2 minus 3 natural log 3. Very good. Any questions here? Any questions, please?
Is that bad?
This is it. You wanna, if you wanna put in the calculator, you can, and then you can check. Okay, next problem. Which one? Okay, so log base 9 of x minus 5 plus log base 9 of x plus 3 equals 1. Okay, my first question would be, what type of equation this is? What type is it? Log, very good. I know that log is not a friendly function, which means I have to state two restrictions, one for this and one for this. What do I have to write for this to exist? Say it again. No. It cannot be 0, but it cannot be negative. The quantity x minus 5 has to be greater than 0. Mandatory. It has to be a positive number, not 0. What about the domain of the second one? Please review the problems we did. This is very important. What is the condition that I have to write and then solve for this one to exist? X plus 3. Very good. So then I have two conditions, x greater than 5 and x greater than negative 3. X greater than 5 is from here, and x greater than negative 3 is from here. I find the intersection, because I have to find the common domain of these two functions. So the first one is 5 to infinity. The other one is negative 3 to infinity. I have to choose the common domain because I want both to exist at the same time. Okay, so then the common domain will be awesome. 5 to infinity. In other words, what does this mean is if the solution is not a number strictly greater than 5, I will say no solutions. Good. I go back to the problem now. And I want to do what? I want to condense. I need to condense. So how do I condense the left-hand side, please? Say it again. Log base 9 of x minus 5 times x plus 3. Log of a product is the sum of logs. So one more time, if you want to go backwards, log of a product will be log base 9 of x minus 5 plus log base 9 of x plus 3. Now, I do what? Here's your hint. What does this mean? What am I telling you? Yes, into an exponential equation, starting with the base. The base, counterclockwise, raised to equals times, very good. 9 to the first power is x minus 5 times x plus 3. I distribute, combine like terms, move 9, set it equal to 0, blah, blah, blah. So x squared plus 3x minus 5x is negative 2x, minus 15 and minus 9. Take a moment and calculate. And tell me if you get the same thing. Do we agree? Do we agree? Say yes or no. Yes? Did we all get this? Okay, so now x minus 6. Very good. So therefore, there are two options. X equals 6. And I will say to myself, not so fast. What does this mean? Very good, awesome. Next problem. Please remember how to solve log equations. A lot of steps in log equations.
How did we get x squared minus 2x minus 3?
X times x is x squared, positive 3x minus 5x is negative 2x, negative 5 times 3 is negative 15, minus 9, negative 24. And then we factor it. Okay, 4 raised to 2x minus 1 equals 1 over 32 raised to 2 minus x. My first question to myself is what type of equation I'm looking at. What type of equation am I looking at? Exponential, awesome. The next question to myself is this. Can I present both sides with the same base? Because if I can, I don't want to go through the applying log and blah, 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 blah. The left-hand side can be presented with a base of 2, which is a prime number. So 2 raised to which power is 4? Very good. So I just replaced 4 by 2 squared, and I copy the rest. I'm hoping that the right-hand side can be presented with which base? That's my hope. So is there a number that I raised 2 to get 1 over 32? I'm hoping I can find one.
Negative 8.
Very good. So now I'm happy. Both sides can be presented with the same base. I don't have to go through the hassle of applying log. Is it wrong if I apply log? No. Will I get the same answer? Of course. So then I copy the base, and what happens to the exponents? Say it again. Copy the base. What happens to the exponents? When we raise an exponential notation to a power, we copy the base and, thank you. So 4x minus 2, we multiply the exponents. I copy the base, and then what is the exponent? Negative 10 plus 5x. At this stage, remember what I'm asking myself. Here's my question to myself. Two numbers are equal, and they have the same base. What is mandatory to happen here? One more time. Two numbers are equal, and they have the same base. What has to happen here? Dictate, please. Awesome. 4x minus 2 equals negative 10 plus 5x. How do I solve this? What type of equation is this now? Linear, very good. So I move 5x to the other side, I get negative x. And I move negative 2 to the other side, and I get negative 8. As you notice, it's exponential. Anything goes. Friendly. So how much is x? Very good. You can go back and check if you want to. Any questions?
When you end up having, I maybe I have another problem, but when you end up having the same base,
Yes?
usually you end up canceling the
I'm not canceling. Please do not say that. I'm not simplifying. I'm not canceling. I'm not eliminating. I'm thinking. So here's the thinking process.
Okay.
Two numbers are equal, and they have the same base. Therefore, these exponents must be the same.
I see. Feels like canceling.
No.
Right.
Awesome. Good. Anything else for me? These are not part of this test. Moving on. Find the domain of the function. State the domain in interval notation. So we have f of x equals log 2 minus x. Okay, so what do I do in this situation? In order to determine the domain of this function. Before I forget, I cannot stress enough. If you do these problems, that's where I'm going to select problems for the test. If you do these problems 10 times, and similar ones, and you do these problems 10 times, you should get an A+ on the test. I'm going to select from here. No secret. Okay. What do I have to write to find the domain of this function? What should I write? Very good. Of course, this is what we just did a minute ago. Maybe 10. Right? This is what we just did. We wrote x minus 5 greater than 0 and x plus 3 greater than 0. Awesome. Thank you. So then I have negative x greater than negative 2. I divide or multiply both sides by negative 1. What do I get? Say it again.
X is less than 2.
Very good. So then the domain of this function is?
Less than 2.
Very good. To 2. Awesome. So please remember the domain of a log function. Okay, moving on. Here it is. Graph the function using transformations. Present the transformations in order of operations. Find x and y intercepts algebraically. Graph the asymptotes. Find the domain and range. Ready? So here's the function f of x equals negative 2 raised to x minus 3 and plus 4. What is the base function used in creating this function? What is the base function that was used here? Very good. 2 to the x is the base function. Awesome. First transformation in order of operations on 2 to the x. First step. Very good. Awesome. 2 raised to x minus 3. What does this transformation do to the base function 2 to the x? what does it do to it? Right 3. Very good. Awesome. Step number 2 is a transformation on function from number 1 in order of operations. Excellent. What does this multiplication by -1 outside of the function do? Exactly. Awesome. You're right. Reflect with respect to the x-axis. Perfect. Step number 3, transformation number 3 is on function number 2. Plus 4. -2 raised to x minus 3 plus 4. What does this mean? That's it. I will determine the x and y intercepts algebraically, but I want to have a rough graph before I continue. Now, how do I graph 2 to the x? There are two possibilities for exponential function. If the base is greater than 1, it looks like this. If the base is greater than 1. If the base is less than 1, it looks like this. Decreasing all the time or increasing all the time? Which one is it? First one. Where does it cross the y-axis? Very good. Awesome. Gee, I think I tortured you well. Good. 1. So this is 2 to the x. Awesome. You told me to move this graph 3 to the right. Here's my marker. This point is at 0, 1, and now I'm going to move it again where? So it will be at 3, 1, correct? Good. Here's the graph. This is 2 raised to x minus 3. Then you told me to reflect this graph with respect to the x-axis. Here's my point. This point will move where? Yes, right here, right? At 3, but -1. So I'm graphing -2 raised to x minus 3. Final step, what do I do with the blue graph? Move it up 4. Very good. So now please tell me, where does my point go? The point that I'm using to keep everything in shape. It goes to 1, 2, 3, 4. But what do I have to do? What do I have to do first?
Y-intercept.
No. The asymptote. The asymptote is at y equals 0. Where does it go now? Awesome. 1, 2, 3, 4. Y equals 4 now is the horizontal asymptote. And now I'm ready to graph. This is the final graph. This one. I'm going to just make it so that it's totally different than the rest. So this is the final graph. It may not be perfect, but definitely this is the shape. Why am I saying it may not be perfect? It's because I really don't know. I did not calculate the x and y intercepts. So domain or real numbers, can anyone give us the range of this function? -infinity to 4. Very good. Awesome. Okay. So we graphed the function using transformations. We presented them in order of operations. We graphed the asymptote. We found the domain and range. The only left thing is find the x and y intercepts algebraically. Good. So now, one more time, the function is, I'm copying it here, -2 raised to x minus 3 and plus 4. I want to find the x-intercept and the y-intercept. How do I find the x-intercept? Awesome. So 0 equals negative 2 raised to x minus 3 plus 4. Okay. What type of equation is this? And how do I start? Correct. Very good. So I have negative 4 equals negative 2 to x minus 3. Very good. Next. Remember, I have to clean it up. It's not cleaned up.
On a base.
Not yet. It's not cleaned up.
Multiply.
Both sides by?
-1.
Yes. So now it's cleaned up. And yes, because it's an exponential equation, I really hope that I can present both sides with the same base. Because it will be straightforward and I will not have to apply log. But if I can present both sides with the same base, then I have no choice. I will eventually have to apply log. 2 squared indeed equals 2 to x minus 3. I don't cancel, I don't simplify, I don't eliminate, I don't touch anything. I think. Two numbers are equal and they have the same base. What has to happen to their exponent? They have to equal each other. So 2 equals x minus 3, so x equals 5. So the ordered pair is this right here, 5 comma 0. I determined it algebraically. Perfect. That was the x-intercept. How do I find the y-intercept? Very good. So then I have to find f of 0. Let's do this together. 0 minus 3, negative 3. 2 raised to negative 3 is 1 over 8. 1 over 8 with minus in front. Negative 1 over 8 plus 4. 8 times 4, 32 minus 1, 31 over 8. Whatever that means. It's right here. This point is 0 comma 31 over 8. And I determine the x and y intercepts algebraically. We have solved this problem in the past, but let's do it one more time. Any questions on this problem? You did pretty well. I'm very happy. You remember the transformations. You remember the asymptotes. Awesome. Okay. So do we want to do this problem? Okay, let's do it. So f of t equals 500,000 divided by 1 plus 2499 times e to negative 0.92t. It models the number of people. So f of t is number of people. Take notes when I read. Number of people. Perfect. F of t in a city who have become ill with influenza t weeks after its initial outbreak. T is in weeks. How many people became ill with the flu when the epidemic began? What does that mean? What am I asked to find? Very good. F of 0. Leave it alone for a moment. Part B. How many people were ill by the end of the 6th week? F of 6 indeed. Leave it alone for a moment. What is the limiting size of the population that can get ill? In other words, as t increases without bound, f of t will approach what? So let's put the function in the graphing calculator. I hope it allows me to. In y equals. Oh, please. Okay, so the function is 500,000 divided by, do I have 500,000? Yes, I do. In parentheses, 1 plus 2499 e in parentheses negative 0.92x 92x. Close the parenthesis for the power and close the parenthesis for the denominator. Be very careful. So now with second and table, I have to go back to the table set because this is okay. So second and table, I want to determine 0. I want to determine 6. And then when t increases without bound, I'm going to say 50 weeks, and then 70 weeks, and then 100 weeks. So what is the limiting size of the population? What is the maximum that can happen? 500,000. So this is 500,000 people. What does this mean about this function? Horizontal asymptote. Y equals 500. 500,000. Horizontal asymptote. At 0, we determined 200 people were sick initially, got sick initially, and then 45,411 people.
That's how you answer that in the calculator.
How you answer it?
How you answer it.
I'm not sure about the question. What do you mean?
Just y equals.
So I put in the y equals.
E is.
It's the natural log. It's in blue.
Alright.
Any questions on this function? Problem, question, anything?
Can you explain more about?
About?
Yeah, can you explain that again?
Which one? Which part?
The limiting size.
As time increases, 20 weeks, 30 weeks, 50 weeks, 100 weeks, and I look at what happens. Yeah. Say it again.
What is the limiting size? Like, is that how we determine?
500,000.
Oh, right.
No matter what I plug in, I get 500,000. No matter how long the answer is always 500,000. It's right here.
Okay.
No matter how many weeks.
Okay.
Okay, problem 6 is not part of your test. Expand the following expression using the properties of logs. Problem 7. So we have log base 2 x, the square root of x minus 1 over 3x plus 4. Good. After that, problem 8 is not part of this test. It was part of the previous test. And then we look at problem 9, and then problem 10. And problem 11 is not part of your test. So after this, 9 and 10, and then we look at the other one. So here we are given an expression inside a log. It's a complicated expression, and they want us to expand this to very simple logs. Where do I start? I start with log base 2 applied to a ratio, which is log base 2 of x times the square root of x minus 1, but minus log base 2 of 3x plus 4. That is my starting point. Log applied to a ratio is the difference of logs. Log applied to the top minus log applied to the bottom. Okay, there is nothing I can do to this. This is completely done. There is no property for log applied to a sum. But now I have to look at log applied to a product, because this is a product. How do I change that? So can anyone dictate? Log base 2 of, yes? Very good. Yes. Now I do have one more property that I can apply here. Not on this and not on this, but on the middle one, which is a power. So what is the square root? What power is the square root? And please do not say 2.
1 over 2.
1 over 2. So then 1 over 2 goes in front. So log base 2 of x plus 1 over 2, log base 2 in parentheses x minus 1, minus log base 2 in parentheses 3x plus 4. And this is it. No one can further do anything here. There are no more properties of the log that we can apply here. Any questions on this?
How did you get the one?
the square root of x minus 1 is x minus 1 raised to 1/2, and then I brought 1/2 in front. Better? Good. Okay, here's problem 9. We are given f of x 80 e to negative 0.5x plus 20 describes the percentage of information f of x that a particular person remembers x weeks after. So this is in percentage of information, and x is number of weeks. Good. After learning the information, find the percentage of information remembered at the moment it is first learned. What do I have to find? Good. Then I have after 1 week. Then I have after 4 weeks. And then after 52 weeks. After how many weeks does the percentage drop to 50%? And leave that alone for a moment. So let's go to y equals. Clear. And let's punch in 80. 80 e to minus 0.5x in parentheses. Close the parenthesis. And outside plus 20. And then with second and table, it's doing crazy things. Okay, 0, 1, 4, and 52. Okay, so for 1, 68.5%. No, I'm sorry, I meant for 0.
0 is 100%.
I wrote it in the wrong spot. Sorry about that. Good. For after 1 week, it's 68.5%. After 4 weeks, it's 30.8. And after a year is 20%. So final question of this problem. After how many weeks does the percentage drop to 50%? So what am I asked to find, and how do I set it up, and where is the starting point? No.
And we can't use the tables to determine this. We don't get it to us.
So we are told when will the percentage drop to 50%?
So 80
Yes? What do I do?
So 80 e to the
So 80 e to negative 0.5, no, 0.5x, yes,
with the x net
plus 20 equals 50 indeed. That's the equation I need to solve for t or x in this case. I have to find x such that the function equals 50%. Remember, factor, simplify, and clean it up. I need to clean it up. Please tell me the first step towards cleaning this up. Very good. 80 e to negative 0.5x equals 30. Good? Very good, but not good enough.
And by 8.
Divide by 80, of course. 3 over 8 till it's completely cleaned up. You cannot apply natural log before it's completely cleaned up. Now, do I have to apply natural log, or can I present e and 3 over 8 with the same base? I cannot. Very good. I have to apply log. Since I have base e here, I'm going to apply natural log. So negative 0.5x times natural log e, but natural log e equals 1. Very good, awesome. Natural log of 3 over 8. So then how much is x? Final step. Very good, yes. Thank you. So x approximately, I can determine this by hand. I have to put in the graphing calculator. So I have natural log 3 over 8. And divide everything by negative 0.5. And I got 1.96. What does that mean? 1.96 weeks. Very good. So that's why please do not try to punch in numbers in order to figure out 1.96. You have to solve the equation. Is that clear?
Can you go back to how you put in the calculator? Natural log.
You mean this one?
And the very first thing.
Okay,
Yes, thank you.
very good. Okay, here it is. Last problem from this test that pertains to our test next Monday. In 2000, I take notes as I read. In the year 2000, the population of Israel was approximately 6.04 million. By 2050, it is projected to grow to 10 million. A of t is the model, A0 e to kt. You know me, I don't really like this. N of t, N0 e to rt. It doesn't matter. You use the one you like. T is the number of years after 2000. So t equals 0 represents the year 2000. Find an exponential function that models the data. What do I need to do? What is given in the problem? I will read the problem one more time, and I will say this. In the year 2000, 6.04. In the year 2050, 10 million. T is the number of years since 2000, so then t equals 0 is 2000. And I need to find the model. This is the function. That's clear. Now I don't have to do anything here, but I have to find the initial population, and I have to find the growth rate. And A and T have to be there. So what is given in this problem?
0 equals 6.04 million.
So very good. 0, 6.04. And very good, 10. Awesome. So we are given two ordered pairs. Perfect. Because I'm told in 2000 and t equals 0 represents 2000, then I know what A0 is or N0 is. So what is this?
6.04.
So for now, I do have the model. A of t equals 6.04 e to kt. This was used, and it's done. But I have not used the second point. How do I plug in the second point in the function? Please dictate. Slowly, carefully. Careful. Careful. What is this for the second point? What is this for the second point?
Years since 2000.
What is this for the second point? No, it cannot be x. It's the function.
Y.
Right, which is
10.
10. Good. That's okay. That's okay. I know it's late. 6.04 times e, and please tell me what else I have to put in there.
R.
No, I don't have r or k.
You do get T.
Yes. How much?
50.
50k. Very good.
Times 50.
Good. I have to solve what type of equation now? Exponential. I have to clean it up before I do anything. How do I clean this up? Very good. 10 over 6.04 equals e to 50k. Can I present e and 10 over 6.04 with the same base? No. So what is my only chance? Awesome. Natural log to both sides. So then I have natural log 10 over 6.04, and can anyone dictate the right-hand side?
50K.
50k. Times 1 is you're correct. So then k equals natural log 10 over 6.04. Everything divided by 50. So natural log 10 divided by 6.04 close divided by 50. And the answer is 0.01. 4 digits. 0.0100. 01. Because I move 1, 2, 3, 4. Yes. So finally I have the model. A of t equals 6.04. E to 0.0101 t. I determined both unknowns, the growth rate, and I determined the initial value, the initial number of the population. Now I can answer, having the model, I can answer the second question.
How did you get the point K for 0.010?
I divide it.
That's what it.
Is that okay?
Yeah, that's just what I got. But you said L.
Yeah, so because this is 8, I move this up. Find the year in which Israel's population will reach 8 million. Find the year in which it will reach 8 million. Please dictate. Yes. Equals.
0.0140101.
Perfect.
It's not on the paper.
Oh, yeah, I'm sorry. Thank you. So, what type of equation is it, and what do I have to do first? I have to clean it up. It's not cleaned up, it's not ready for natural log. I have to. Very good. Now I'm ready. Say it again.
Is it 0.01 or is it 0.0?
0.010.
So cross the 1 out on that.
You mean here? It was 0, I changed it to 1.
Oh, okay.
0.1008.
So natural log 8 over 6.04 equals 0.0101 t. So therefore t equals natural log 8 over 6.04 divided by 0.101. So I put in the graphing calculator. Natural log of 8 over 6.04. So natural log 8 divided by 6.04 and divided by, and I can divide by the previous answer because I'm lazy and I don't want to put it in. So roughly 28. 28 what? Yes, indeed, 28 years. In 2028, it appears that the population will reach 8 million. So that was what did I do? Oh, here it is. So that was pretty much everything here. Now, what I would like to do on Wednesday is do another example with matrices, Gauss-Jordan, elimination, review systems, and do more examples from 8.1. So, any questions from me, please?